So today we're going to talk about adding and subtracting rational expressions, which means finding common denominators. So when adding or subtracting rational expressions, you have to remember that we're following the rules of fractions. So when you add or subtract a fraction, you have to add the same denominator. You have to have the same one. So for a simple example, 4/5 plus 3/10. Are 5 and 10 the same number? The answer, and this will shock you, is no. So what we have to do here is we have to get a common denominator. Now some might say that the common denominator is 50, but we actually have a lower common denominator than that, and that's 10, because, well, 5 times 2 is 10. So what I want to do is I want to get the denominator of that first equation to have a denominator of 10. So if I multiply the bottom by 10, I also have to multiply the top by 10, because 2 over 2 is basically I'm multiplying it by 1. So at that point, 4 times 2 is 8, 5 times 2 is 10. We get 8 over 10 plus 3 over 10, which means we can combine them. 8 plus 3 is 11/10. So there we go. We're going to add or subtract some rational equations now just to try it out. So here's our first one. So when I look, I'm trying to find a common denominator. In this case, I have a common denominator of 2, 6. So let's see. My lowest common denominator, it's not going to be 12. It's actually, 6. So that means I'm going to have to multiply by 3 on top and bottom. So that becomes 3x over 6 plus 7x over 6, which of course becomes 10x over 6. And guess what? Wait a second. I was about to say we're done, but we're not. Because 10 over 6 can be simplified, meaning 5x over 6. And that, right there, is our final answer. Now let's try another one. So this one says negative 2a over 3 plus 3b over 4 minus a. So let's see. Lowest common denominator. Unfortunately, 3 and 4 don't have any common denominators until I multiply them by the other. So 3 times 4 is 12, 4 times 3 is 12. And this a is really a over 1. So we'll go to 12 there too. So let's see. This is going to be times 4 on top and bottom, so negative 8a over 12. This is going to be times 3 on top and bottom, so 9b over 12. And finally, this is going to be times 12 on top and bottom, so minus 12a over 12. So let's see. Negative 8 plus... Wait a second, I can't add these. They have different variables. I can only add this a with other a's, which would be all the way down here. So negative 8 minus 12 ends up becoming negative 20a. And then plus 9b, because there are no other b's, all over 12. And if you look, none of those terms have common denominators, meaning that is our answer. Let's try another one. Ooh, so as you can see right here, we're now starting to use the letter x in the denominator. So let's talk about how we figure out what our least common denominator would be here. So I'm just going to look and see what factors are there missing from each side. So if you look, first thing I'm looking for is numbers. I only see a 2 on our right equation. So I'm going to multiply the first part by 2, which means this is also times 2. Now let's go to our next part. There are no x squareds over here, so that means this is going to become... Alright, and the only other thing that's missing is we have a y on this side, but we have 2 y's over here, so this becomes times y times y. So, now I'm just going to multiply it out. So 2y times 2x is 4. You know what? I'm going to change my color to red. 4xy plus 2y, I distributed that out, minus 3x squared, all over 2x squared y squared. All right, let's try another. So in this case, hey, this question is simple. We have the same denominator in both. So 2 plus 4x is just, well, 4x plus 2. All over 2x minus 3. Guess what? We're done. Awesome. Let's try another. All right, so let's see what we're missing on each side. So on the left side, all we're missing, it looks like, that's on the right, is a 4, meaning this one becomes a 4. But on the right side, we're actually missing a whole x minus 6. So this becomes 3x times x minus 6. So let's see. 3x times x is 3x squared minus 18x plus 4 all over 4 times x minus 6 times x plus 2. All right, so let's try another one. All right, if you look at this one, I need to find my common denominator, but to do that, I first have to factor out both denominators. So, first thing I'm going to notice before I try anything else is, look, 3, 9, and 6, those all have a common multiple of 3. So this is really 3 times x squared minus 3x plus 2, meaning 3 times x minus 2 times x minus 1. Now, let's try another one. So this, once again, we have a common denominator, in this case, of 3. So this becomes 3 times x squared plus x minus 2, meaning 3 times x plus 2 times x minus 1. So if you look, the big thing missing from our right side, which I'm going to draw a line to keep that, is we are missing the x minus 1. And, oh, not x minus 1, x plus 2. Now on our left side, what we're missing is x minus 2. So let's see. As I multiply those out, I get x squared plus 2x minus, let's see, 2x. 2x times negative 2 is negative 4x. But because I'm subtracting, it becomes plus 4x and then minus x plus 2. So we're going to start combining our terms. In this case, it becomes negative x squared plus 5x plus 2 all over 3 times x plus 2 times x minus 2 times x minus 1. And there we go. So now we're going to quickly talk about complex fractions. A complex fraction is one that has a fraction in the numerator and or denominator of the bigger fraction. You might have seen one on earlier homework that looked kind of like this. Ooh, spooky. Our goal in simplifying these types of problems is to get rid of the fractions inside the fractions. We don't want to have an inception's worth of fractions here. So here's an example of a complex fraction. It says 1 over x divided by 2 over y. But here's the thing, we've done that before. It's just we wrote it like this, 1 over x divided by 2 over y. So the only thing that we'd do is we'd say 1 over x times y over 2, meaning our final answer would be y over 2x. And guess what? That's our answer. Let's try another. Oh, we made it harder. That makes me sad. But luckily, this isn't that hard. It's just I have to take my top equation. This becomes 3x over x if I want to combine them. So that becomes 3x plus 1 over x. And then on the bottom, this becomes 4y plus 5 over y, But remember, because we're dividing, it becomes y over 4y plus 5. So our final answer ends up being 3xy plus y over 4xy plus 5x. All right, so now what we're going to do is find our least common denominator for each sum or difference and then state our restrictions. All we're doing here, notice, is finding the least common denominator. Do I have to multiply out all of this? No. I don't have to know that it ends up being 6x plus 1. All I need to know is that the least common denominator between 3 and 15 is going to be 15. That's really it. Okay, so now let's try this one. So I would have to go x plus 1 times x minus 1. And this is x times, let's write it in a different color, x times x plus 1. So let's see, what's missing from our first one? Well, from our first one, we're missing an x. But if you look, the x plus 1 is in both, so x plus 1. And then we're missing an x minus 1. Meaning this would be our final one. Oh, we have to state some restrictions, by the way. I didn't do that on the last one because, well, whole numbers don't have restrictions, but this one does. So let's see. In this case, we know x cannot equal -1, 0, or 1. So there we go. And guess what? We're done with this. Congratulations! You've learned how to add or subtract rational equations. Please feel free to subscribe to to my page, and if you need any help on any other terms, feel free to watch the videos I posted over those. Thank you very much and have a great day.